Next, we're going to work through number 5 on the limiting and excess reactant worksheet. If a reaction vessel contains 0.15 moles of KO2 and 0.10 moles of H2O, how many moles of oxygen can be produced? So we're going to notice that we are starting out with our moles of both reactants, and the end goal is to convert to moles of product that can be produced. So we're going to utilize our BCA table again in this example, just like the question we just worked together. So we first want to start out by listing the amount of moles that we have before the reaction occurs. So first, the problem states we have 0.15 moles of KO2. So we'll go ahead and fill that in on our BCA table. We also note that the starting amount of moles of water is 0.10. So we'll take a moment to fill that in. Next, you'll see that I blacked out the table underneath KOH, and that's simply because the problem does not ask anything about KOH, so there's no need to worry about it. And then underneath our oxygen on the product side, you'll notice that I filled in a 0 because the reaction hasn't started yet, so no product has been produced quite yet. So that's going to be a 0. So next, we need to determine which of our reactants is going to run out first. So remember, the limiting reactant always determines the maximum amount of product that can be produced. So before we can even look at converting to moles of oxygen, we first need to look at which reactant is going to run out first. And the way that we do that is we can start with moles of either reactant and convert to moles of the other reactant. So in this problem, I'm going to start with 0.15 moles of KO2, and I'm going to convert that to moles of H2O. So the way we do this is really simple. It's a one-step railroad track, and we're going to use our molar ratio to help us make this conversion. So we're starting out with our 0.15 moles of KO2. We copy and paste that unit and substance moles of KO2 down diagonally, and then we put our moles of H2O on top. So when you have moles of one substance over moles of another substance, remember we want to fill that in using our mole ratio from the coefficients in the balanced chemical equation. So you end up with, for every 2 moles of water, there are 4 moles of KO2. So when we multiply across the top and divide by the denominator, you should get 0.075 moles of water. So what this conversion is telling me is that if I start with 0.15 moles of KO2, then I must need 0.075 moles of water. So the next question we want to ask ourselves is, do we have enough water? So if we need 0.075, we want to look at the amount of moles given in the problem to see, do I have enough? So we were given the starting amount of 0.1 moles of water. So yes, we have more than enough. So water is going to be our excess reactant in this problem. So out of the 0.1, 0.075 moles are going to be used up. So we can fill that in the moles consumed or moles changed section of our BCA table. So out of the 0.1, we know that 0.075 moles will be used up. And once that many moles of water are used up, then the reaction is going to stop because we ran out of the other reactant. So if we want to determine how many moles are left over, we just subtract 0.1 and 0.075, and you get 0.025 moles. That would be left over because water, again, is our excess reactant. So with that being said, now we're going to look at our KO2. Out of this 0.15 moles, all 0.15 moles is used up because this is our limiting reactant. So after the reaction has gone to completion, there's no moles of that reactant remaining. So that's actually number 6. It asks which reactant is limiting. It would be KO2. That's your limiting reactant. So now that we know the limiting, we can very easily determine the amount of product produced. So we need to start with our limiting reactant, which again is KO2, and we need to convert that to moles of product produced. So this will be another one-step railroad track, very simple. We're starting out with that 0.15 moles of KO2 because that was our limiting reactant. We'll copy and paste the unit and substance down diagonally, and then we want moles of oxygen on top. So when we have moles of one substance over moles of another substance, we're just going to look to the coefficients in the balanced chemical equation to help us determine the relationship between oxygen and KO2. So you'll notice for every 3 moles of oxygen, we have 4 moles of KO2. So we're taking our 0.15 times 3 divided by 4, and you should get a grand total of 0.11 moles of oxygen. So that's the amount of oxygen that is produced and will remain after the reaction has gone to completion. So that would be your final answer to number 5. We have 0.11 moles of oxygen. So hopefully that makes sense. If you have any questions, feel free to reach out to your chemistry teacher. As always, we're always happy to help y'all. So get some practice in on your own and let us know if you have any questions. Have a great day.